Hi all of you. I am Sandeep DH. So from this video I am going to solve previous year's papers of Kset questions and with solutions. So first I will solve 2013 paper of part 2. So here in this video I am going to solve mathematical physics part. Okay. So let's see. So this is the question number 1. In the question number 1, it is given the matrix 1 by root 2, I by root 2, minus I by root 2 and minus 1 by root 2 is only Hermitian, only unitary, Hermitian and unitary, and fourth option is neither Hermitian nor unitary. See, this is the question number 1, the paper, the Kset paper, that is the matrix, the given matrix is given. In that matrix elements 1 by root 2, I by root 2, minus I by root 2 and minus 1 by root 2. Whether we have to verify is the given matrix is our only Hermitian or only unitary or Hermitian and unitary or neither Hermitian nor unitary. That means it is not Hermitian or not unitary. Okay. So let us see. So first we know that Hermitian matrix means A is equal to A dagger. A dagger means first we have to take a complex conjugate of the given elements of A and we have to transpose. And unitary means A dagger gives identity matrix I. Okay. So let's see. For example, consider this is a matrix A. A is equal to 1 by root 2, I by root 2, minus I by root 2 and minus 1 by root 2. And A dagger means, see, we know that A dagger means first we have to take a complex conjugate of A and we have to transpose. So let's see, A dagger is equal to, let us take a complex conjugate of the matrix A. So 1 by root 2 and I imaginary part complex conjugate is minus I by root 2 and minus I by root 2 is plus I by root 2 and minus 1 by root 2. And we have to take a transpose. That means you have to change rows and columns of the elements. So then it will gives, so 1 by root 2 and so this column matrix is tends to row matrix. So this is I by root 2 and this is minus I by root 2 and this is minus 1 by root 2. So we can see that here the matrix A is 1 by root 2, I by root 2, minus I by root 2 and minus 1 by root 2. The obtained matrix is same as the A matrix. So that is 1 by root 2, I by root 2, minus I by root 2 and minus 1 by root 2. So A is equal to A dagger. So A is equal to A dagger. So the given matrix is Hermitian. So it is Hermitian and the only Hermitian, so it is not possible to, now it is not easy to say that, and only a unitary, so this is not possible. And neither Hermitian nor unitary, this is also not possible. So but now we have to verify whether it is a unitary or not. So for that, unitary matrix means we know that the matrix multiplication A dagger is equal to I. So let us take A is this one and A dagger is also same this one and we have to square this. So that means we have to take a 1 by root 2, I by root 2, minus I by root 2 and minus 1 by root 2. So Let us take a matrix multiplication. One by root 2 into 1 by root 2, 1 by 2, I by root 2 into minus I by root 2. So I into I square is minus 1. Again here minus is there, minus into minus plus. So 1 by 2 plus 1 by 2, 1. And here 1 by root 2, I by root 2 and minus I by root 2. So it will 0. And if you take a matrix multiplication, it gives 1 0 0 1. So which is identity matrix. So we can easily say that A dagger is equal to identity matrix I. So therefore the given matrix is both Hermitian and as well as unitary. So option C is correct. Okay. So Hermitian matrix means we have to check whether A is equal to A dagger. A dagger means first we have to interchange the rows into column or column into rows, and we have to change the complex conjugate of the matrix. Otherwise first we have to change the complex conjugate of the matrix and again interchange the rows and to travel into a column. So if A is equal to A dagger, then it is Hermitian. And unitary means if you have to take a matrix multiplication of A into A dagger. So once again I am repeating, if A dagger is equal to I, so then it is a unitary matrix. So the given matrix is both Hermitian and as well as unitary. Okay. So this is the question number 2, which is what is the product of eigenvalues of? So the given matrix is, the matrix elements is alpha 1 0, 0 beta 1 and 0 0 gamma, and this is the given options. So here they ask what is the product of eigenvalues. So we have to first find out the eigenvalues of the given matrix and we have to take a product. So then we have to verify whether in the given option it is there or not. But for that, to calculate eigenvalues, we have so many methods. First we have to take a characteristic root equation and we have to find. But here it's better to use the properties of a eigenvalues and eigenvectors. We know that the properties of eigenvalues and eigenvectors says that if we add the given eigenvalues of the matrix which gives trace, okay, and if we take a product of the given eigenvalues which is the determinant of the matrix. So here we have to go through the property number 2. So first we have to take a determinant and we have to multiply the given eigenvalues. So let's see. So the property number 1 is the sum of eigenvalues gives trace of the given matrix, and the product of the eigenvalues gives determinant. So determinant of the given matrix. So let's do the calculation. So let us take a determinant of the given matrix. So alpha is equal to beta into gamma, 0 into 1. So beta gamma minus 1 into, so 0 0 and plus 0 into 0. So the determinant is alpha beta gamma. And we know that the property number 2 says that the product of the eigenvalues is the determinant. See, and if we add the eigenvalues, it gives the trace. So the trace is alpha plus beta plus gamma. If we add the eigenvalues, it gives alpha plus beta plus gamma. If we take a product of these elements, it gives alpha beta gamma. This is determinant. So in the given options, option number D is correct. We can easily verify that, right? So here the trace of the matrix, the trace is nothing but sum of the diagonal elements of the matrix. So which is alpha plus beta plus gamma. And the product of the determinant is not nothing but alpha beta gamma. So obviously this is the eigenvalues. These are the eigenvalues of the given matrix. Okay. So this is the question number 3, which is the given equation d square z by dx square minus 2x dz by dx plus 2 lambda z is equal to 0 is called Legendre's equation or Bessel's equation or Hermit equation or Beltram's equation. So these are the differential equations. So we have to verify the given differential equation is whether belongs to these differential equations. Okay. So in the special functions there is a definite one or two questions for this Kset exams. Okay. Definitely they will ask verify whether this type of equations, or they will ask to calculate first few parameters of the Legendre or associate Legendre polynomials, like that. So let's see the Legendre equation, the Legendre differential equation is of the form 1 minus x square d square y by dx square minus 2x dy by dx plus L into L plus 1 into y is equal to 0. Okay. So this is the Legendre polynomial equation. We can easily verify this is the special function, the special symbol which is used in quantum mechanics. If there is L into L plus 1 in the coefficient of y, we can easily get this is a Legendre polynomial. Next, and Bessel's equation. So here it is x square d square y by dx square plus x into dy by dx and plus x square minus nu square of y is equal to 0. So there is a lot of difference for Legendre equations and Bessel's equation. See here the d square y by dx coefficient is x square, and here it is x, and in the y coefficient we can see again the variable x square minus square. So if the equation is like this, so then we can easily say this is a Bessel's equation. Next, and a Hermit equation. So let's see what is the form of Hermit differential equation. So that is d square y by dx square, okay, minus 2x dy by dx plus lambda into y is equal to 0. See, we can easily say that the given equation is in the form of d square y by dx square minus 2x dy by dx plus lambda into y. So we can easily say that the given equation is Hermit equation. And this is also very useful in quantum mechanics, so you should always remember this equation. And the another last option is Beltram's equation. So that is f of z is actually used in complex analysis. F of z is equal to mu into f z. So this is Beltramian differential equation. Actually this is used in complex analysis. Okay. So while going for exams, it's better to go through these equations. Next. So this is the question number 5. Okay. So in the next video I will upload the question number 4. So let's go to the question number 5. This is using Fourier series expansion of x square in the interval minus 5 to 5. Actually in the Kset questions they will given minus 5 to 5, but this is not a limits, which is minus pi to pi plus pi. So this is the limits. The value of summation n is equal to 1 to infinity 1 by n square is. So actually in the Kset questions, Laplace equation, there is a question from Fourier series and Fourier transformation and Laplace transformation. If you cover these 3 topics, definitely you can get 6 to 8 marks. Okay. So let's see. We know that the Fourier series expansion equation is f of x is equal to a naught plus summation n is equal to 1 to infinity a n cos nx plus summation n is equal to 1 to infinity b n sin nx. Okay. So let's first I will calculate A naught. A naught is equal to 1 by 2 pi integration minus pi to pi f of x dx. So which is equal to 1 by 2 pi integration minus pi to pi. The f of x given function is this one. So this x square is our f of x. So x square into dx, which is equal to 1 by 2 pi differentiation of integration of x square gives x cube by 3, and let take a limit minus pi to pi. Okay. So and this gives 1 by 2 pi into pi cube. After substituting this upper limit and lower limit, pi cube minus of minus pi cube, 2 pi cube by 3. So 2 pi cube by 3, and this 2 cancel, and pi cube, so the remaining is pi square by 3. So our A naught is pi square by 3. Next, it's better to go to calculate an. You have to calculate an and substitute here, and you have to calculate bn and you have to substitute here, and you have to take a total equation. And see, next an is, so this is A naught. An is 1 by pi into integration minus pi to pi f of x cos nx dx. Okay. So which is equal to 1 by pi integration minus pi to pi f of x is nothing but x square into cos nx dx, which is equal to 1 by pi into, okay, so it's better to solve here, and 1 by pi into integration, we have to take integration by parts. So that is, first we have to retain this x square here and integrate this cos nx. Integration of cos nx is sin nx, sin nx divided by n, and again we have to take alternative minus and plus. So minus differentiation of this first term, so that is 2x, and again integration of this term, so that is integration of sin x is nothing but cos minus cos x. So minus cos nx divided by n, but one more n is there, so here we can write n square, and again plus differentiation of 2x is nothing but 2, and here integration of cos nx, integration of cos is nothing but sine, but here it is minus sign is there, so minus sine nx divided by n, but one more here n square is there, so better to write n cube. Okay. So and let's apply minus pi to pi, the limit. Next, so 1 by pi into x square. See, if you apply the limit minus pi to pi, the sine function will be 0 anyway, because sine any pi is 0, and the second term is cos, so that is here minus into minus plus 2x, right? So this term is 0, and it is 2x cos nx divided by n square into minus pi to pi, and again the term is sine, so again the terms will give 0 because sine any pi is 0, and which is equal to 1 by pi into 2 into, let us take 2 is a constant as outside, 2 into x is nothing but pi into cos n pi by n square, and minus minus into minus plus pi into cos n pi divided by n square, and cos pi cos n pi by n square, pi cos n pi by n square is nothing but 2. So 2 2s are 4 by pi into cos n pi by n square. Since cos n pi is nothing but minus 1 power n, since cos n pi is equal to minus 1 power n, so therefore an is equal to 4 by pi into minus 1 power n. So we have to substitute this an here. So therefore an is nothing but 4 by pi minus 1 power whole power n. And bn, next we have to calculate the bn. See, bn is nothing but 1 by pi into integration minus pi to pi f of x sin x, and 1 by pi into integration minus pi to pi x square sin x into dx sin nx into dx. But see, so this is a even function, this is a odd function, so the bn gives 0. The contribution of bn is 0. So now we have to substitute this a0, an and bn to the given equation f of x here. Suppose consider this is a equation number 1 and bn is equal to 0. We have to substitute all these a0, an and bn. So let's see. So we know that the given function is f of x is equal to a0 plus summation n is equal to 0 to infinity, 1 to infinity an cos nx plus summation n is equal to 1 to infinity bn sin nx. So we know that an is, so f of x is equal to a0. a0 is nothing but pi square by 3 plus summation n is equal to 1 to infinity an is nothing but 4 by pi minus 1 whole power n. So I am writing here 4 by pi minus 1 whole power n into cos nx. Actually, sorry, here I forgot to write n square. So this is 4 by pi by n square. In the denominator n square is there, I forgot to write that. So it is n square. And next plus bn is 0. And the given function f of x is nothing but x square. Okay? And put x is equal to pi. If you take x is equal to pi, it will become pi square. So pi square is equal to pi square by 3 plus 4 by pi. Okay, so 1 minute. So actually here pi is not coming in the given function an. So we know that, so this is 4 pi. An is equal to 4 pi divided by pi into minus 1 whole power n divided by n square. So pi gets cancelled. So here pi into minus 1 power n into cos nx divided by n square. So if we expand this, we will get, see, minus 1 power n, minus 1 power n. If n is equal to 1, it will again minus. So minus cos, put pi, so cos pi divided by 1 square, and again if n is equal to 2, it will plus cos 2 pi divided by 2 square plus cos minus, because n cube, so minus 1 cube is minus cos 3 pi divided by 3 square, so on. Okay. So after expanding this, we will get pi square is equal to pi square by 3 plus 4 into minus cos pi is minus 1, minus into minus 1, minus into minus plus, so 1 by 1 square plus cos 2 pi is 1, so therefore 1 by 2 square, and cos 3 pi is minus 1, again minus into minus plus, so 1 by 3 square. So if we expand this, we will get finally 1 by n square. So therefore, this term in the left side which gives, so therefore pi square is equal to pi square by 3 plus 4 into 1 by n square, and therefore if you send this, if you rearrange the equation, above equation, then will gives 3 pi square minus pi square by 3, which is equal to 4 by n square. 3 pi square by 3 is nothing but 2 pi square by 3, 2 pi square by 3, and if 4 comes here, it will becomes 4 is equal to 1 by n square. And 2, 4 cancel, and which is 1 by n square is equal to pi square by 6. So this is our answer. So the expected answer is pi square by 6. So option number D is correct. In the given question, option number D is question. Actually this question seems, actually the Fourier series and Fourier transformation questions looks like a very lengthy, but if we practice this, it's very easy, because all the questions in the Fourier series and the Fourier transformation is in the similar type questions. Either way they will give x square, or they will give x, or they will give some constant. If you remember the series, f of x is equal to that a naught plus a n and cos n x, sin n x, so definitely it's easy to remember, but it seems it's look like a lengthy problem. So this is question number 6. The first property of the orthogonality relation for the Legendre polynomial is given by minus 1 to plus 1 Pm of x into Pn of x dx is equal to 0. So this condition is 0 when the given option is m is equal to n, or m is equal to n is equal to 0, or m is not equal to n, or m is equal to n is equal to 1. So it's a easy question. Whenever they will ask about the orthogonality, you can just go through this condition. So that is any function, okay. So the any function, the limits, for example minus 1 to plus 1 Pm of x, Pn of x is equal to dou m n, whatever maybe this is, phi m or phi n, okay, psi m, psi n, whatever may be the notations. The given condition is equal to 1 if m is equal to n, and is equal to 0 if m is not equal to n, okay. So here the question is Pm of x into Pn of x into dx is equal to 0 when, see, it is 0. When m is not equal to n, so then this integral is equal to 0. So this is orthogonality condition, okay. Is equal to 1 only if this is Pn of x into Pn of x, or Pm of x into Pm of x, that is limit minus 1 to 1 Pm of x into Pn of x into dx is equal to 1. Otherwise Pn of x into, Pm of x into Pm of x is equal to 1. Otherwise Pn of x into Pn of x into dx is equal to 1. So this is the orthogonality condition. Okay, so it is very easy question. So option B is correct. So for the Poisson distribution, the standard deviation sigma is related to the mean m. So here that's the relation for mean m and standard deviation. So that is, always you should remember Okay, sorry, this is not a options. See, sigma is equal to root m, or sigma square is equal to root m, and sigma plus m is equal to 0, and sigma is equal to m. So we can easily guess by our option, in the given option. See, sigma square is not obviously equal to root of m, and sigma plus m is not equal to 0, and sigma is not equal to m. Sigma is equal to root m, sigma square is equal to m in the Poisson distribution, the relation for mean and sigma, and here sigma is equal to root m. Option A is correct. And for this topic, from this topic also at least 2 or 3 questions. Poisson distributions or probability distributions. Okay, so every time they will ask questions are related to these topics. So let's see question number 8. So the question number 8 is the value of k. You have to calculate the value of k for the function f of x is equal to e power minus kx, and the function is varies from limit 0 to infinity. So we have to calculate the probability of a distribution function, the probability of a function from 0 to infinity. Okay, so from this in this region 0 to infinity, for this function, what is the value of k? See, so for the probability distributions, we have an equation or formula 0 to infinity f of x dx is equal to 1, and integration 0 to infinity f of x is nothing but e power minus kx dx is equal to 1. And we have a formula, a general formula, that is integration 0 to infinity e power minus ax dx is equal to 1 by a. So therefore, this equation gives 1 by a means k. So 1 by k is equal to 1. So therefore, k is equal to 1 is the answer. So k is equal to 1. So option C is correct answer. Okay. So these are the mathematical part questions from 2013 paper for a part A, and in the next video I will calculate or I will discuss a part 3 questions and mathematical physics related. Okay. So first I will solve year-wise mathematical part questions, and the next I will go through next part like classical mechanics and quantum mechanics, electronics, condensed matter physics. See, for a Kset they will ask for I think 75 questions, maybe 200 marks. I think 200 marks. Earlier it is for 300 marks. So for from each subject they will ask at least 10 questions. They will frame for 10 questions, and each questions carry 2 marks. It's better to cover all the topics with, it's better try to remember all the formulas. And for Kset they will frame a questions from a selected topics only. We can go through from 2013 to 2020 paper. They will cover only for a selected topics. From that selected topics, you should remember all the top formulas or concept. You should understand the concept. Then it's very easy to crack this Kset exam. Okay.